Hi, welcome to the video training of Elixir, and in today's video training we will be learning about control flow structures in Elixir. We will be looking at case, condition, if and unless, and do and blocks. First, let's look at case. Case allows us to compare a value against many patterns using until we find the matching one. So let's enter the interactive mode of Elixir and let's type in case, pass in the list and do 4, 5, 6, enter. Then we have 1, x, 3, we have the underscore and the end statement. Okay, we needed to add arrow function after the 5, 6 case do statement. So let's do this again. Do 4, 5, 6 space arrow function and okay, it says no case clause matching 1 to 3. An expression is always required on the right side of arrow value after right arrow. So what we need to do here is start from the beginning, and then we have the list 4, 5, 6 and the arrow function. Then we have a string, this clause won't match. Then we have another list 1, x, 3 and then the arrow and the string, this clause will match and bind x to 2 in this clause. Underscore arrow and the last string, this clause would match any value, and what result we get in the end is this clause will match and bind x to 2 in this clause. So that's we got in the end. Basically we ran a pattern matching control flow, inputting different lists and their results in this control flow, and when we entered end at the end we got the result. So if you want to pattern match against an existing variable, you need to use the pin operator. So let's see how it works. Equal 1, so 1 case 10 do and pin operator x arrow won't match underscore arrow and will match end. So we get will match. Clauses also allow extra conditions to be specified via guards. Let's see this, how this works. One, 3 when x is greater than 0 we will show will match, otherwise we will show would match if guard condition were not satisfied, and we'll get will match. The first clause above will only match when x is positive. Keep in mind, errors in guards do not leak but simply make the guard fail. So let's try HD1. Got argument error. So let's do this. Case 1, do x when HD, x arrow won't match, and x equals got hash x end. Okay, we got 1. If none of the clauses match, an error is raised. So if we go with case OK, do error won't match, got an error, no case clause matching. Note, anonymous functions can also have multiple clauses and guards. So let's write a function f equals fn comma y when x is greater than 0, x plus y, x comma y equals x multiplied by y, and okay, let's run our function f dot 1 comma 3. We get 4 because 1 plus 3 is 4. But what if we pass -1 and 3? We get -3. The number of arguments in each anonymous function clause needs to be the same, otherwise an error is raised. Let's declare another function f2 comma 1 when x is greater than 0, arrow x plus y, x comma y comma z, x multiplied by y plus z, and we get an error saying cannot mix clauses with different arities in anonymous functions. Now let's move on to condition. Case is useful when you need to match against different values. However, in many circumstances we want to check different conditions and find the first one that does not evaluate to nil or false. In such cases, one may use condition COND. Do 2 plus 2 5 equals, and this will not be true. Okay, then we have 2 multiplied by 2, 3, nor this, and then we have 1 plus 1 equal to, say, but this will. Let's end it, and we get but this will. What happened here is 2 plus 2 is not equal to 5, so the result was this will not be true. Then we tried 2 into 2, which is 4. It is also not equal to 3, so we got nor this, but the last statement 1 plus 1 is equal to 2, and we got but this will. This is equivalent to else if clauses in many imperative languages, although used much less frequently here. If all of the conditions return nil or false, an error condition clause error is raised. For this reason, it may be necessary to add a final condition. equal to true, which will always match. So let's try the same example we did earlier, but this time we will not going to create a valid statement, but we will going to use true, which will act as a else, and it will run if none of the conditions are true. This is always true equivalent to else, and that's what we got. This is always true. So this acts as an else like in other languages. Finally, note condition considers any value besides nil and false to be true. And do hd pass in the tuple one is considered as true, and we got one is considered as true. If and unless. Besides case and condition, Elixir also provides the macros if true and unless true, which are useful when you need to check for only one condition. So if true, do this works, and we got this works. So unless true, do this will never be seen, and nil, we get nil. If the condition given to if to return false or nil, the body given between do and is not executed, and instead it returns nil. The opposite happens with unless. They also support else blocks. So if I say if nil do, this won't be seen, and let's type in the else block, this will, and we got this will. Do and blocks. At this point we have learned 4 control structures: case, condition, if and unless, and they were all wrapped in do and blocks. It happens we could also write if as follows: if true, comma, do colon 1 plus 2, we get 3. Notice how the example above has a comma between true and do. That's because it is using Elixir's regular syntax, where each argument is separated by a comma. We say this syntax is using keyword lists. We can pass else using keywords too. So if false, do colon this, else that, we got that. Do and blocks are syntactic convenience built on top of the keyword ones. That's why do and blocks do not require a comma between the previous argument and the block. They are useful exactly because they remove the verbosity when writing blocks of code. These are equivalent. So if I go with if true, do a equals 1 plus 2, a plus 10, we get 13. And if I try if true, comma, do colon bracket a equals 1 plus 2, a plus 10, bracket close, got the same result. One thing to keep in mind when using do and blocks is that they are always bound to the outermost function call. For example, the following expression is underscore number. If true, do 1 plus 2 and we got a compilation error saying undefined function is number. Would be parsed as is number if true, do 1 plus 2 and it will throw the same error, undefined function is number, which leads to an undefined function error because that invocation passes 2 argument and is number does not exist. The if true expression is invalid in itself because it's a block, but since the arity of is number does not match, Elixir does not even reach its evaluation. Adding explicit parenthesis is enough to bind the block to if. So if we use if is number, if true, do 1 plus 2 and bracket close, we get true. Okay, that's it for this video training of Elixir, and don't forget to subscribe to my channel if you like this video. See you next time with a new topic in Elixir.